Hello friends, let's work on this GRE problem, geometry problem. So the problem statement is like the diagram is shown to you, a circle is there and a diameter AB is there, points C and D are there, and the connecting lines are there, AC, CB, DB and AD. So it's given that diameter is 5 units and the length CB and DB are given to be 4. And we are required to find the area of the shaded portion, right? So area of shaded portion is basically area of two triangles, triangle ACB and triangle ADB. If we are able to find the area of these two triangles, we can add them up and we'll be able to find the area of the shaded portion as in the diagram, right? This complete area. So for circles, we have to remember that if a diameter is given right here, and it's a special property of circles that if you take any point on the circle with diameter like this, and if we draw any line like this connecting one end of the circle, one end of the diameter to that point, and another line like this, then this angle will always be 90 degree. Whichever point you take, whether you take this point and draw lines like this will be 90 degree. This is a special property of circles, right? This angle will always be 90 degree. So you have to remember that special property of circles, right? 90 degree value, right, of the angle if the angle is drawn like this, taking diameter, and you take any point right here, whatever point you may take, E, F, G, everywhere the angle will be 90 degree. So this property you should know of the circle to be able to solve this problem. Now we know that this is a right triangle, right, ACB, and we know the length of AB to be 5 and the length of CB to be 4. Now another important property of any right triangle is that the hypotenuse square is equal to perpendicular square plus base square. This is Pythagoras theorem. If you don't know, you can review the Pythagoras theorem as well. You can review circles as well, like what all different properties of circles are there, area of circle, circumference, and you can go over all of these concepts, and then the Pythagoras theorem, right? So if we apply Pythagoras theorem here, so hypotenuse will be, hypotenuse is the side which is opposite to the 90 degree angle, right? So AB is the hypotenuse, it will be equal to AC square plus BC square. So AB is 5 square is equal to AC, we have to, we don't know, we have to find out that, and BC is 4 degree. Why we need to find AC, it will just become apparent in some seconds. So if we solve this, AC square is equal to 25, 5 square is 25, minus 4 square is 16, which is equal to 9. So AC will be equal to 3 units, right? AC becomes 3. So similarly on the other side we have a exactly same triangle, similar triangle with this, the base 4, the hypotenuse 5, and this other side has 4. So this will also come out to be 3, because this is again 90 degree here. We need not do all those calculations. Now what was our intention of finding AC? Why we wanted to find AC? Because we know that in a right angled triangle, or for that matter in any triangle, the area of the triangle is half into base into height. So here base is BC, so in this case it's half into BC into AC, right? This is 90 degrees, so we can, if we take BC as base, the height will be AC, right? And if you take AC as the base, the height will be BC, right? So half into 4 is BC into 3, so it comes out to be 6 square unit is the area of this triangle, and the other triangle is symmetrical, so its area will also be 6. So 12 is the answer. So option D is the answer. So basically to solve this problem you should have good knowledge of circles, Basically you should know this property of 90-degree thing, first thing. Second, you should know Pythagoras theorem, right? If you don't know that, how you can revisit the Pythagoras theorem. And the third is the area of triangle formula. You should have solved a lot of problems for this, right? Why we found AC, it became apparent when we applied this formula, half into base into height. So if you know these three concepts, you'll be able to solve any problem. So practice more and more and go through the basic concepts of circles, triangles, and all other geometry concepts to be able to become strong in solving GRE geometry problems. Thank you so much. Have a good day. Bye.